project was applying some concepts that we've learned this year to yo-yoing, because I like to yo-yo. So I videotaped myself yo-yoing, and I got some data and analyzed it in Logger Pro. First, I looked at the vertical distance. There was also the x inches, which is the horizontal distance, but since the yo-yo is pretty much the motion that we care about is going up and down, I looked at the vertical distance. And it looks pretty much like it can be modeled by a parabola. But what I wanted to do was to compare it going down to it going up, so I did it with two different parabolas. So here's the vertical distance moving down, and then this would be the first half of the motion, so imagine the yo-yo falling and being at the bottom would be about here, and then, Liza? And then going up would be from here, which would be about the ground or the part where it's stopped before it makes its trail back up, all the way there. And then you can compare them and see that even though it looks like one parabola might fit, if you were to do a best fit for all the points, it would actually be quite off, and it works better to do two, one for the way down and one for the way up. And if you were to look at the slope at a point on the parabola, over here it's much steeper. It's pretty much the steepest up here, gets less steep, and then here, even at its steepest part, it is less steep than when it first begins falling. So what this means is that if you were to take the slope in different places, you would find velocities, because velocity is speed in a direction. And it's also represented by distance over time and the derivative. It is a concept we work with a lot. So now we can look at the velocity. And since that was a parabola, the derivative would be a linear function. So this is the whole motion. And again, I wanted to split it up to the going down and the going up. And you can see that since it's in a direction, the negatives would be the negative direction going down, which would be this data, and then going up. And this little part is going back into my hand, that's why it's a little weird and doesn't follow the pattern. So I discounted those final dots. And I looked at them separately to compare the motions of going down and then going up, and then both of them at once. And then what I was also able to find is that when the velocity is almost zero when they cross, right here, and that would be in the vertical parabola right at the bottom, where if you were to put your pencil, it would be flat, so the slope would be zero. It would be at the 4.05 second mark when it was in that position of basically being at a full stop before it came back up. And then the question is that I also started thinking about for the project is why does the yo-yo move faster going down? And this is the easier question because it's pretty logical. Does anyone have a guess? James?
You got gravity?
Yes. So, I mean, not so much of a surprise. The more surprising thing was, next slide, why the yo-yo slows down as it falls instead of speeding up, because most objects, when they're falling, would get faster as they're getting closer to the ground, and this doesn't do that. No, Eliza, you know. Sophie? Oh, were you raising your hand?
I think Dylan's raising his hand.
Dylan?
Friction?
Yes, friction. So there's a string there, and it's providing some resistance, so instead of an object just like free falling, the pencil getting faster, it has something like almost like a track that's stopping it. And so even though the path downwards from your hand has a larger velocity than the path upwards, as it falls, it gets slower, which is perhaps not what you would expect. And then another application of the equations that you get from the different graphs are you can find out how fast the yo-yo is moving at a certain time. So, for example, 4.151 seconds, how fast is the yo-yo moving? And you would put that in for the x value of time in your velocity, and then the y you would get would be the speed, the inches per second. So, how many people think it's A? No. Okay. B. Okay. C.
Always good.
Okay. D.
I'm changing my answer to B.
You're right.
Oh.
So, it is going 22.3 inches per second at this time marker, and that's another thing you can figure out with the equations. So, are there any questions? Diana?
How long have you been yo-yoing for?
Well,
How long have you been yo-yoing for?
well, when I was younger, I yo-yoed probably when I was like 9 or 10, and then I did that for a few months. At one point, I had a yo-yo with my name written on it, written on the yo-yo, like engraved kind of, which I asked for. So, I was into it for a few months, and then I stopped, and then a little bit at JuliaL and started again. Sophie?
Why did you choose to do this project?
Because, I don't know, I got a yo-yo at Common Ground, which is broken now, but started yo-yoing again, and I was talking to Steve about how nobody had really, cared to think of yo-yoing through a mathematical lens. So I thought, you know what, it's something that I like, and it would be interesting, and I could analyze a video of me actually doing the motion of yo-yoing instead of just, a thing that I wasn't as directly involved in. Cool. Steve?
Do you have a stable full of yo-yos at home?
Do I have a stable?
Yeah, stable.
I don't have a stable.
Like horses.
No, I have a
Do
stable.
you have multiple yo-yos at home?
Do I have multiple?
Yeah, multiple, like a whole stable.
Yes, there was one point where here I had 3.
3. What's the most that you've ever had at one time?
Most yo-yos at one
Yeah.
time?
In a stable.
In a stable,
I think
as opposed to the kitchen.
the stable kind of maxes out at 4, I
4.
think, probably.
What do you look for in a yo-yo?
It's funny that you would ask. There are things that one would look for. I like yo-yos that you can make them looser or tighter because then you can do different tricks with them. Yeah. And also if they're really light, they're not that good. It has to have some weight to it. Cool. James?
Sort of related, but I apologize because I came in late, so I'm not sure if you did this, but
Yes.
it sounds like you videotaped it
I did.
using a singular yo-yo.
Yeah.
Did you do the same video trial with these other yo-yos that you have? To see,
No.
because you said I would choose it differently for, you can adjust that tension or,
Yeah.
So what would you maybe anticipate if there was how would that parabola change or the velocity change if you had, doubled the tension on it?
Yeah.
Or
Well,
halved the tension?
one thing that you can do, one trick that you can do is make it stay at the bottom for a few seconds before it comes up by loosening the yo-yo. So if you did the same, if you analyzed a video doing that trick where it would stay at the bottom, then the distance parabola would probably have more level spot where it's not moving because the velocity would be 0 for longer because for that time that it's at the bottom, it's not moving any distance. So yeah, it would kind of be, I would predict it would be shallower for longer, but just in less time. So perhaps compressed graph.
I wonder though, if it seemed like one of the things you were saying is that the velocity change. Is it one thing where if it's sitting at the bottom, that you could potentially, do you think it's possible that the velocity going down could actually be matched with a comparable velocity going up? Do you think you could adjust it so that you could match those velocities?
I don't think so, because even if you were to do that, the principles that made it not in the standard trial would still apply. Gravity, I don't think could be counteracted just by having it rev up at the bottom for a while. And it usually actually comes up slower after it stays at the bottom. I've noticed just from doing it. It doesn't make it faster. Do you have a question, Steve?
I do have a question.
Yes.
I was wondering, what do you think would happen if we did this in outer space
Without gravity?
without gravity? Or there's still gravity there, but gravitational forces are much less, right? So
Well, it will be different.
do you think a yo-yo would work?
Not the way it works here.
I wonder how it would be.
And I'm sure it would, if it were to work, it would work differently.
Because going back to the question about how gravity affects the up's velocity, if we remove gravity, I'm wondering whether they would match themselves, the down and up velocities.
Maybe they would, because gravity seems to be the thing that's making it go faster as it goes down, because it's not fighting the force. So if it was not there, then it would probably level it out more, logically, I would say, but I don't know.
And one way to find out,
I've never
Julia,
yo-yoed in space,
and
Steve.
there'll be future missions in space,
Yeah.
looking for people, yo-yoists.
Should write-
Is that what you call yourselves, yo-yoists?
I mean, I'm sure it's a term that's probably somebody's used that before. I don't identify as a yo-yoist, Steve, but
How do you identify?
a recreational yo-yoer is
Okay.
what I like.
Yo-yoer,
Yes.
Yo-yoer.
yo-yoer,
Yo-yoer. It can be used, yeah, I would say.
awesome. That's awesome.
Yeah.